Here we go on the second video, and now we're going to be focusing on dividing, right? This idea of turning a division problem into a multiplication problem. So I'm gonna give you an example, and hopefully this makes sense, right? So let's say we have $4, right? And basically I'm asking you, this is 0.25. Basically I'm asking you, if you have $4, but they're all in a bag of quarters, how many do you have? Well, that has to be 16, right? There's 4 quarters in $1. So if you have $4, that means you have to have 16 quarters, right? And so that's why it makes sense that when we divide 4 by 0.25, right? Even though it looks like maybe it will get smaller, no, it's in fact going to get larger because we have more of this 0.25 than we do of dollars, right? We have way more quarters than the dollar bills. So now let's say we rewrote this as a fraction, 4 divided by, let's say 1 over 4, right? Because 1 over 4 is 0.25, right? You know, it's just 0.25. And now the question becomes, well, how would you turn this to a multiplication problem? Well, the first thing we could do is say, well, 4 is this divided sign just means divide is being divided by 1 over 4. Okay, now the question is, what can we do so that when we turn this to a multiplication problem, we get 16? And the only logical thing to do is we have to flip this. We have to take the reciprocal. So it's going to be 4 times 4 divided by 1. Now, if you want to, we could also write this one as 4 divided by 1, right? And now, as you know, we can multiply across. 4 times 4 is 16. All divided by 1 times 1, which is just 1, so it's going to be 16. And you can see that that does match our answers that we wrote right up above. And so whenever we have a division problem such as this, or something like this, right, we can turn it into a division problem like this. And what we can do is now just take the reciprocal and we can flip it, which is basically what the reciprocal means. We just flip it, you know, this. The denominator goes on the numerator goes on denominator, and last but not least, we multiply across. So how do we take those principles and apply it to a problem like this that's going to be a little bit more, I would say, I don't know, a little more challenging? So let's look at something like this. Let's say we have x plus 6, okay? We have x plus 6, and we have, let me think here. I'm trying to think of a nice problem for us to work on. X squared minus 36. Okay. Over here, let's go ahead and do x plus 2. And let's say over here we have x squared plus 4x plus 4. Okay. So here we have this division problem that seems a little rather challenging, and we're not sure how to maybe go about approaching this, right? And so maybe the first thing for us to do before we do any factoring is to just turn it into a multiplication problem. Again, like over here, when we had this division problem, all we did was just flip the top and the bottom to get this expression over here. So if you want to, we could do it that way. It's up to you, honestly, to decide. Some people prefer to factor and turn everything into factor form first, and some other people prefer to turn it to multiplication. We'll just do the multiplication. So we turn this, well, this has to go on the denominator and this has to go on the numerator. So let's just go ahead and rewrite it as x squared plus 4x plus 4, all divided by x squared minus 36. Okay, so that's all it do. Whenever we have a division problem, all we have to do is just flip it, and now it becomes a multiplication problem, right? And so now, well, all we have to do is just factor the top and the bottom. So these first terms stay the same, x plus 6, x plus 2. If you want to, you can put parentheses around it so that you're reminded that that's an entire factor. We can't just separate them apart. Okay, now we go over here and we turn this into factored form. Well, this right here, all the factors of 4 are 1, 4, 2, 2. And so for me, I think at this point I'm feeling pretty confident that I could do some of these hopefully in my head. All right, there we go. 2 plus 2 gives me the 4, but 2 times 2 does indeed give me the 4 over there. Last but not least, this is all going to be divided by, well, I can put a 0x in the middle, and hopefully by now we're kind of getting this idea that whenever we have this middle term, right, what two numbers multiply to give you 36, but when we add them, it's 0. And you can see that it's always going to be Well, 6 times 6 gives me 36, so I just flip the signs on one of them, and that's going to work, right? 6 minus 6 is going to give me the 0x, and 6 times negative 6 does indeed, in fact, give me the negative 36. Now that I have this expression here, okay, well, if you want to, we can combine it on top, right? We can just write it as x plus 6, x plus 2, x plus 2, all divided by x plus 2, x plus 6, and x minus 6. Okay, now that we have this right here, now if we have the same factors on top or bottom, we can proceed to cancel them out. So these x plus 6 cancel out, x plus 2 cancel out, and so we're left with just x plus 2, all divided by x minus 6. Okay, and if you wanted to, originally you could have just done, well, this cancels out with this cancels out with that, so all we're left with in the numerator is this, which is right here, and the denominator, which is right there, and this becomes my final simplified answer. There's nothing else I could do. All right, well, let's go ahead and maybe look at another example here. Let's say, let me go ahead and find one I think that it's worth maybe going over. Okay, I think there's one that's a bit challenging. Let's do it. Let's go ahead and write x to the 4th minus 9x squared. This definitely looks a lot more challenging, so why not? Let's go ahead and do that. X squared minus 4x plus 3 divided by, oh, sorry, I had a sneeze there. Silly old me. X to the 4th to the 3rd minus 8x squared, all divided by x squared minus 16. Okay, so again, when we're doing a problem that is division, maybe the first thing you like to do is just turn it straight into a multiplication problem, right? So let's just go ahead and write this as x to the 4th minus 9x squared, all divided by x squared minus 4x plus 3, multiplied by x to the 4th plus 2x to the 3rd minus 8x squared. Oops, sorry. I forgot to flip it. I'm so silly. Okay, multiplied by, now we take the reciprocal, right? To turn this into a multiplication problem, again, you can't forget this goes on the numerator and this goes on the denominator. So this is going to be x squared minus 16 all divided by x to the 4th plus 2x to the 3rd minus 8x squared. Okay, there we go. We turned it. The biggest hurdle is just turn it to a multiplication problem, and now we just proceed like we've done in the other videos. So one of the things that makes this problem uniquely different is that we have this x to the 4th and x to the 4th, right? And we were usually just dealing with problems that look like this right here and this right here, which were quadratic. So the great news is, because if we look here, this term has x to the 4th and this term has x squared. Well, we can factor out, just like, remember we had this problem here, we had 4x plus 20. Well, when we went to factor that out, right, we got 4x plus 5, okay? Because 4 times x is 4x and 4 times 5 is 20. So what that basically means is we're going to do the same thing, except instead of with like a 4 here, we're going to do it with the lowest term, which is x squared that's available there. So now what we're going to do is continue going and doing that. So basically what that is going to look like is we're going to get x squared. Over here, I'm going to put parentheses. Okay, so we have x to the 4th minus 9x squared. Essentially, what we're trying to do is pull out an x squared, right? Because this is the lowest number of x's that's on that term there. And so what we want to do is pull it out. And so the question becomes, right, what can we do to this times this, is going to give me this term right here. And so if you want to, what you can essentially do is divide out x squared to both sides, so you can see how that looks like. Well, x to the 4th divided by x squared, sorry, that looks bad, it's just going to be x squared. And this cancels out, we get minus 9. Okay, So x squared times x squared does indeed give me x to the fourth, and x squared times negative 9 does indeed give me negative 9x squared. So this is going to be x squared minus 9. Okay, I'm going to factor the bottom. The bottom is going to be x minus 3, x minus 1. Negative 3 plus negative 1 is negative 4. Negative 3 times negative 1 is going to give me positive 3. All right, now let's go ahead and go over here. Well, again, I feel pretty confident, right? On the top, we can factor this as x plus 4 and x minus 4, right? Now, if you have a question on how I'm factoring this, you can leave a message on the comment box and I'll kind of explain it more in depth. Hopefully in the previous videos, you got an idea of how that works. Again, 4 minus 4 gives me 0 because there's no x in the middle term. And 4 times negative 4 does in fact give me negative 16. All right, now to factor this bottom part, again, maybe if it's helpful, I'll write it out over here. X to the fourth plus 2x to the third minus 8x squared. Okay. Now I'll look at the very lowest term, which is x squared, and that's probably what we're going to have to pull out. So we should get x squared, right? So I'm going to get x squared and parentheses around here. Now x squared times this first term should give me that x to the fourth. So that's going to be x squared plus, and then x squared times this should give me the 2x to the third, right? So that's got to be 2x. And last but not least, the last term is going to be minus 8. Okay, now that we got this problem right here, okay, now we're almost done here, but we're going to rewrite everything and factor out the bottom. So we have x squared minus 9. Well, before we proceed, let's go ahead and factor out the top. We have x squared, and we're also going to now be able to, now that we pulled that out, we can see, well, this right here is just going to be x plus 3, x minus 3, and on the bottom we have x minus 3 and x minus 1. Over here we have x plus 4, x minus 4, all divided by x squared. And now we can factor this out right here. And we're going to get this right here. Now, I'll write all the factors of a. Maybe this one is one that I'd like to maybe go over, which is 2 and 4. And so I can now see that if I do negative 2 plus 4, I will definitely satisfy this in here. And so we'll do x minus 2, x plus 4. Okay, so now that I have this expression here, now we can go ahead, now that everything's fully in factored form, I can now look and see if I can multiply anything. Well, we have this x minus 3 here, and we have this x minus 3 here. That's going to cancel. I have an x plus 4 and an x plus 4 here to cancel out. And I look around and we have this x squared and x squared, which will cancel out. All right, so all that's going to be left in the numerator is going to be x plus 3 and x minus 4. So x plus 3, x minus 4, all divided by x minus 1 and x minus 2. Okay. Now if you want to, you can basically just use a distributive property and distribute this out to get x squared minus 1x minus 12, all divided by x squared minus 3x plus 2. And again, this is going to be my final answer right there. So you can see that problem was a little more challenging and took a little bit more work, but hopefully we feel